I have a cubic polynomial function. That means it has to have 3 zeros and 3 linear factors. So keeping those things in mind, I'm going to answer parts A, B, and C here. So part A says that this polynomial has 1 0 that's an integer, and we're going to find it graphically. Okay, so that means I'm looking for an x-intercept that crosses the x-axis at an integer. So I go to y equals, I'm going to type in this function 2x cubed minus 16x squared plus 32x minus 10. And I'll just start with a standard window, zoom 6, and hope I can see the place where it crosses at an integer. Okay, so the first two x-intercepts looks like they don't go through a tick mark, but that third one kind of looks like it might go right through a tick mark. Okay, so I've got this one right here. Looks like it goes through, and it looks like it's at 1, 2, 3, 4, 5. Looks like x equals 5. And I would like to check that, right? And I can check by going to my table. And if I type in x equals 5, if I'm right, the y value should be 0. It is. Okay, good. So x equals 5 is, in fact, my integer 0. Okay, so this would be part A, x equals 5. All right, so part B says the function has 2 irrational zeros. So that would be this point and this point. I want to find their exact value, which means I cannot use my calculator to get those, because my calculator will give me a decimal approximation. So if I want to know their exact value, I have to divide. So I'm going to take my original function, 2x cubed minus 16x squared plus 32x minus 10, and I have to divide by the factor that I now know. So I know that x equals 5 is a 0, which means I know that x minus 5 is a factor. So I'm going to divide x minus 5 into p of x using long division. So I ask myself, I look at just the leading terms, the x and the 2x cubed, and I say, what do I multiply x by to make 2x cubed? And the answer would be 2x squared. So I put that over the x squared term. And then you multiply your 2x squared times your x minus 5. So 2x squared times x is 2x cubed. 2x squared times negative 5 is negative 10x squared. And then I have to subtract. So 2x cubed minus 2x cubed goes away. And then I have negative 16x squared minus negative 10x squared. So that's negative 16x squared plus 10x squared gives me negative 6x squared, and I bring down my 32x. And then I start the process again. I look at my leading term in the x minus 5 and the leading term in the negative 6x squared plus 32x, and I say to myself, what should I multiply x by to make negative 6x squared? And I say, oh, negative 6x. And then I multiply it. Negative 6x times x is negative 6x squared. Negative 6x times negative 5 is positive 30x. And I subtract. The negative 6x squareds go away. And then I have 32x minus 30x. And I get 2x, bring down the negative 10. All right, what should I multiply x by to make a 2x? A 2. Distribute my 2 to the x minus 5, and I get 2x minus 10. Subtract. And my remainder is 0. So how does that help me? Well, now I have a quadratic, and I can set it equal to 0 and use the quadratic formula. So I now know that p of x, my cubic polynomial, can be written as x minus 5 times 2x squared minus 6x plus 2. And If I want to set this equal to 0 and solve it, I would say, oh, well, either x minus 5 equals 0, which I already know means x equals 5, or 2x squared minus 6x plus 2 equals 0, and I would solve this using the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. 6 plus or minus 4 times 2 is 8 times 2 is 16. The square root of 36 minus 16 is 20 all over 4. And you could just leave it like that, or we could simplify and say 6 plus or minus 2 root 5 over 4, and then reduce. Divide the numerator and the denominator by 2, and I get 3 plus or minus root 5 over 2. Okay, I forget that. Okay, so now I know my cubic polynomial, I know all 3 of its zeros. I know 1 at x equals 5, and then I have 2 at these irrational values, which means I can now write my cubic polynomial in fully factored form. So my original polynomial was 2x cubed minus 16x squared plus 32x plus 10 minus 10. Okay, so now I can factor this so that it has a leading coefficient. I can always factor a third degree polynomial so it has some leading coefficient. And because it's third degree, it's going to have 3 factors, each one looking like x minus a 0. Okay. My leading coefficient is going to be the same as it was when it was all multiplied out, so that's going to be a 2. And now I just plop in my zeros. I have one of them at 5, one of them at 3 plus radical 5 over 2, and one of them at 3 minus radical 5 over 2. So there is my completely factored form of p of x.